The first thing I want to start with today to talk about is this Marin training run, because this is, in my opinion, one of the cooler things that happened this week. And so I'll just kind of like, I haven't really looked into this a lot. Like I briefly looked at it. So I'm not speaking from a position of expertise on this at all, except the fact that what I have seen is super, super, super cool. So this is a project which I actually had like maybe heard about, but I don't think I really knew exactly what it was, which is basically a fully open, community-supported pre-training run. And they're doing, what they're doing is openly training what they hope to be are quite good models. And so if you look at like what they've done so far, this is a pretty cool picture because it shows like, okay, they have a 1.6B model, which is this one that they've already finished. It's only activating 61 million parameters in every forward pass. So like this is like a small model. It's a 1.6B, but it's a mixture of experts. And so like this is a pretty good training curve for a mixture of experts model, meaning they've figured out like a lot of things. They've figured out the right data mix. They've figured out the right stability mechanisms for making their mixture of experts, their experts distributed correctly and make sure that there's no hotspots. But then what this shows is that they've taken that recipe and they've been able to scale it. So they took that 1.6B recipe and trained on 48 billion tokens. They took and they expanded it. They created a 4B parameter model that activates 162 million parameters forward. And they trained that on 128 billion tokens. And so you can see that like it scaled. It did a good job. It didn't have a crazy loss spike somewhere where it never recovered. And you can see if you look at some of these training runs, they don't go as smoothly as this. So they've been scaling up. They did a 11.5B run that looks to be finished as well. And currently they're training this 27.7B one, which is it's starting to get to be that same size as like a Quen 27B. But this is a mixture of experts, so it's only activating 1.2 billion parameters. So this is going to be a really, really fast model. It's all just very exciting. And you can see that like this is extrapolated. This has not been trained yet here. So they're still working on, like, this is still under training run. And what is super cool, this is the part that like started yesterday and is really exciting, is that they are starting training on what they quote as a hero run, which is a 535 billion parameter total with 23 billion parameters active. So this is starting to be to the point where like your everyday computer cannot just run this. But yeah, anyway, what's cool about this is this hero run of a 535B parameter model, which you've got 23 billion parameters active in every forward pass. That's starting to be like, remember when Quen 3.827B it's a dense model, so it's not going to have this 535 billion parameter capacity. But so we're talking about like the speed of the 27B. It's not that different from a speed of a 23B. Depending on, there's many different things here. I mean, the number of active parameters is not necessarily indicative of the speed, but like that's just a rough mental picture that you can have. But yeah, so they built this whole, they plotted this entire curve before they started. That's what's so cool about this, is that they're so confident in their scaling laws and in their extrapolation abilities. They're so confident in the ability to sort of extrapolate from what's happened in all the other data points that they're plotting this ahead of time before they even start their work, which is pretty impressive. And then yeah, so those are the eval curves, I believe. I think these are eval curves, and this is the actual loss curve. So you can see this is the depth 2048, which is that, if you look at the colors, green Light green, dark green. I think it's not matched. I think this is the hero run. You could look at how deep the loss curve on the hero run is. So this is like, that's super exciting, right? Like it's going to be a lot lower. But and I guess I was looking at, this is like where they changed their data mix over here. That's why it kind of jumps up. But I don't know all the details. But okay, so this looks like this is the 1.7B total. This one, the pink one or orange or whatever that color is the 4B. This one here, it looks like it's the, what is it? 11.5B. And yeah, this makes sense because it's not finished training yet. And they have this whole, it's not finished training yet series. So this 27B parameter model looks like it's this, the depth 2048, which makes sense because I think a lot of, when a lot of these LLM companies are training their models, they think of them in like the depth of it. And I'm pretty sure the hero run, they don't put the depth in here, but I think it's like 6,000 something. So it's like way, way deeper. But what is really cool, so first of all, you can download their data. You can, first of all, you can explore their data. Like they give you a whole mix of, and you can open everything. This is the cool button here, just like opens it all. But it shows you the mix that they've chosen. So I think when this says lowest, low, middle, high, highest, I think these are quality levels. Because if you look at and you see the mix, these are open source data sets, and you see the ratios, the ratios at which they mix those in. So this HPLT seems to be like their biggest mix for the lowest tier. And then fine translation seems to be their greatest mix in the highest tier. And it's cool as you can like see. You can actually like see examples of this. So it's just like a cool project. This is a really neat project. So, but that's not it. And you can see, okay, games and gambling, schools and children programs, study skills and academic writing. You can see just like all the different categories they have here. And one of those here, let's like go to software development. So it looks like in the lowest tier, we've got the stack, which is just web data. This is just, I think that's web data. The stack, E3. What is it? Oh, it's source code. It's source code. I actually thought it was random internet data, but it's source. Oh, I'm thinking of the pile. The pile and the stack. Okay, but the stack makes sense. So this is just a giant database of all source code that I'm sure that they could find from anywhere. And then as it gets here, the highest quality one is Nemotron CC code, which is Nemotron. We have so much to thank the NVIDIA folks for because they open source just so much of their data. Like, I mean open source when I say it, because a lot of companies just release open weights and they don't release all the data that goes into their stuff. But NVIDIA has released not everything, but a whole lot of their data and the recipes for how they generate the data too. But so it's cool that you can download this. Like you could literally download all this data if you want. Which is great. It's super cool. But then this is what I was like I was really like kind of like geeking out about, is that you can watch the run live. Wait, where are we? So you can see like as the hero run trains, this is the loss curve. Oh shoot, it's like yeah. So this is the loss curve of that hero. This is what he posted yesterday. This is updated. So I don't know where this was yesterday. Let's see. It was like 1 point, I don't know, 6 something. Where are we at now? Yeah. So we were somewhere around here yesterday, and now we're here, 1.39. So it continues. And look at this graph. Like when you see it, normally when you see these loss curves like this, you see like little spikes, little spike here, little spike there. And the problem is that like whenever you see those spikes, oftentimes it doesn't go back to the same baseline. It's like goes back to a higher baseline, which you don't want. And then you get weird damage to the model. But this means that they've found such a good data mix and such a good training recipe that they just have like the smoothest loss curve ever, which is super cool. And you can, this is live. So you can go back here tomorrow, next week, days from now, weeks from now, and see as it finishes its training run and watch it. And like, there might be problems. Like if something goes wrong, they're gonna have to fix it and solve it, and you'll be able to watch it as it goes. But so this is cool. Like for example, they have a ramp up of their learning rate, and you can see we're already past the peak ramp up stage. So now we're in this like cool down phase of it, or in like the normal, I don't even know what you call that phase, where the learning rate just slowly drops and follows that pattern. And then yeah, this is like, this was the, oh yeah, so this is where they got that picture. You can see it starting to bend a little bit. So this is yesterday, and now it bends a little bit more. So cool. You can see the grad norms. And I believe this macro loss was the same thing that was driving this chart here. So, okay, wait, I wish I could hover over this and see what their prediction was. I'm sure they have it somewhere. But yeah, I don't know. So this is cool. So when this is finished, you can download this model, as I understand it. And then the other thing is, one last thing, on GitHub, you can see that they have all of the planning and all of, like, you can see where they fit those curves before. Oh yeah, and this is where I was saying. So this is like where I said that it was 614. I was saying it's like a 6,000 depth model. You can see that right here. And yeah, you can see also how they're scaling up the tokens. 18 trillion tokens for this one. Man, I'm so excited. Oh, and yeah, so this is the code. This is the code. Grug model config. Oh, that's fun. I actually didn't see that. So yeah, it's all open source. Literally open source. Literally. Not open weights, but open source. And I think, I don't really know much about this Marin project. Wait, let's go to, yeah, and by the way, there's people, like, this is an exciting project. People are pumped about it. And I think we're going to get a lot of learning out of this. But what was I going to say? Oh yeah, like this guy, the Marin project, he's got a link here. I was just clicking around in the Marin project, which seems like it's kind of a cool project. And their launch announcement is basically just saying, look, we're trying to create foundation models and we want it to be open. But the cool thing is that they have, like, Marin seems to be kind of like a library that you can use. So they have like a getting started guide, and you can get started right away. And like they have this thing where you run your first experiment, which I don't really know. I don't really understand how this fits in with the rest. But anyway, I think this is a cool project. I want to learn more about it. I want to like keep watching. I'm gonna keep going back to this weights and biases graph and just keep watching it as it goes, because I have a feeling this model is going to be impressive when it comes out, and I also have a feeling that it's going to be useful. Imagine running this on, like, I don't know, like imagine taking a quant of this once it's finished and running it and like pruning it maybe so that it can run on one of these like DSparks, one of these DGX Sparks. And also the open source people are into it as well. So I don't know. In general, I'm pretty excited about this. I think it's cool. And it's also just like super, super ballsy to predict the loss curve before you start your training run. That requires a lot of confidence, but I understand why they have that confidence based on just like the smoothness of their loss curve so far. Oh, there's a mailing list. That's kind of cool. Gotta ask. Okay, maybe not 100% open. But yeah, sorry, I never scrolled down here. But this is where they actually were making these predictions. They talk about like how they're doing their fit, how they're doing their scaling ladder analysis. Yeah, okay, and then this says data mix phase 2. I don't know what that means. But again, like, it's all open source. I could go look what that means. Oh, here we go. Here's the full source to reproduce the scaling ladders. Yeah. So this is a really cool project. I'm excited to watch it. And I actually think we'll get something out of this that we'll want to use. That's my prediction.